Hello, my name is Kat Wayman, and I am presenting my undergraduate presentation on the research paper titled BERT Pre-Training of Deep Bidirectional Transformers for Language Understanding by the Google AI Language Team. The problem identified within the paper was that, as of 2019 at least, current techniques for applying pre-trained language representations to downstream tasks restrict the power of the pre-trained representations, especially for fine-tuning approaches. Prior language representation models were limited by the use of unidirectional language models, such as left-to-right or right-to-left language models for pre-training. For example, OpenAI GPT utilizes left-to-right architecture, where every token can only attend to previous tokens in the self-attention layers of the transformer. This is suboptimal for sentence-level tasks and can be very harmful when applying fine-tuning based approaches to token-level tasks like answering questions where context is crucial, coming from both directions. The goal of the Google AI team's paper was to introduce a new language representation model that utilizes bidirectional language models for pre-training to demonstrate how a model like this allows for a better understanding of context within generative pre-trained transformers. The literature cited within the paper is divided into three categories: literature pertaining to unsupervised, feature-based approaches, unsupervised fine-tuning approaches, and transfer learning from supervised data. Prior literature referenced in the paper explored unsupervised methods for learning word representation with models like ELMO, utilizing bidirectional language models to extract context-reliant features. Recent approaches following unsupervised fine-tuning approaches involve pre-training and fine-tuning sentence or document encoders for downstream tasks with supervision. Models like OpenAI GPT have received positive results in regard to sentence-level tasks using this method. Finally, transfer learning has been successful with supervised tasks that include large datasets. This is similar to transfer learning in computer vision, where the models are pre-trained with ImageNet. The technical details surrounding BERT include descriptions and visual representations of the model architecture, as well as input and representation. Additionally, an overview of the steps involved with both the pre-training and fine-tuning of BERT were included, as well as specifications of the tasks BERT can handle. The input representation was possible through the use of word piece embeddings. On the screen, I have included the figures within the paper detailing both the pre-training and fine-tuning steps, as well as a figure of BERT's input representation, where the input embeddings are the sum of the token embeddings, segmentation embeddings, and position embeddings. I will now discuss the results of the Google AI language team's findings and how BERT compared to other language models. On the screen are the General Language Understanding Evaluation, or GLUE, test results, where the data represents the number of training examples for each task. Even at a base level, BERT utilizes more training examples in every task compared to other learning models, leading to BERT outperforming all systems with a 4.5 and 7.0 respective % average accuracy improvements over the prior state-of-the-art. This next table shows the results from using the Situations with Adversarial Generations, or SWAG dataset, which contains 13,000 sentence pair completion examples, used to evaluate grounded common sense inference. Basically, the task is to choose the most plausible continuation among 4 choices. Both BERT base level and large versions outperformed all other learning model tests, as well as the human expert performance. In conclusion, the paper emphasizes the impact of BERT on natural language understanding tasks by overcoming the limitation that unidirectional models faced. It highlights the importance of bidirectionality and unsupervised pre-training in achieving state-of-the-art results. The study concludes by highlighting BERT's broad applicability and effectiveness across a wide range of NLP tasks.